Greetings! Today we're going to have a look at this Peavey Midi streamer from the late 80s. Has floppy drive and it's used to store Midi setups from Midi enabled instruments, which they all are now. So what you can do is use a protocol called Midi SysX to send setups to this thing, and it'll store them on the floppy drive, and then you can recall them later and have a collection of floppy disks with all of your setups for your Midi stuff. This one was sold as non-working, didn't come with a power supply, so I guess it's time to power this thing up. It needs a 16 volts AC adapter. So what I think I'm going to do is open it up so we can easily connect 16 volts AC to it and see what it does. Well, let's remove some screws and let's have a look at the back first. It's got two Midi ins, a through and an out, and asking for 16 volts to 16.5 volts AC over here. I don't have a plug right now, so I'm going to open it up and hope that I can clip on to the power input and see what awaits us. I removed the screws holding the top cover in place. But looks like I didn't remove all of the screws. There's one more left. And it still doesn't want to come. Oh yes, there you go. Oh boy. I think I see the problem. There's the problem. It's a rechargeable battery which has leaked all over the place. There's traces running underneath it which have probably been eaten. These four resistors over here, and I gotta pull chips and see what they look like, but there's our problem. But to be complete, I'm gonna power it up anyway. What do we have to lose, right? And see, there's our connector. We can clip on 16 volts over here and see what it looks like. We're going to use the BK Precision AC adjustable AC supply, which is over, where is it? Oh, over here. So all we got to do is take the output with alligator clips, make sure we adjust this to 16 volts, and then clip that on and see what the Peavey will do. Alright, let's fire up the AC supply and dial in 16 volts AC. It's kind of touchy at the lower end, I guess. Close enough. That's right within range. So we turn it off, get rid of this guy, and clip on to the power feed. And let's see what it does. So power on and power on the unit on. The drive lights up. Nothing on the display. It's dead all right. Let's do a quick measurement and see if at least we're getting 5 volts on the board, or if that stuff is gone also. And for that, pick a chip, any chip. Oh no, that one has power at a different place. Let's just take some TTL. And we're getting 5.09 volts. So the 5 volts is running, but that's about all that's running. Oh, by touching the power supply, I guess I reset it. The disk drive light went off. The LCD lit up. It's a 2-line by a 20-character display, and only the top line is all the blocks lit up. At least the LCD is good, but that means that the processor isn't running, or it has not been able to reset the LCD display. So what we got to do is take out the PCB and start working on the damaged area. After removing many screws, we got the PCB out. Quick tour. We got a Motorola 68000 as the main processor. We got RAM. Of course, we got 2 of everything because this runs it's a 16-bit. We have a 16-bit data bus here. 2 EEPROMs, more RAM, 2 asynchronous communications interface adapters, 6850s, because it's got 2 Midi ins. A WD, what is it, 1772 floppy disk controller, this guy, and everything that ties it together. The only weird thing that threw me for a loop was this thing, which looks like an audio amplifier, but it's actually a switching supply controller. So they put this in. This thing is a 5-volt switching supply controller. Even though it has a floppy, the floppy is a 5-volt only, dual-sided, dual-density, 800K per disk device. 5 volts seems to be there. So the first thing we got to do is get this battery out here and see how bad it looks underneath. The battery came out in one piece. It actually doesn't look that horrible. Of course it's dead, but I didn't add any more damage. We see stuff here is corroded. This is where the battery sat. These resistors got hit here, and it started propagating onto this chip. But that is, there's nothing else that looks corroded. Top is a different story, of course. So there's what it looks like. A lot of things got hit here. This is the chip that may have been affected, and these are the 4, well actually 3 resistors in the cap. So the first thing we're going to do is bathe the affected area with vinegar to hopefully neutralize and clean up the battery leakage. I did a lot of cleaning, soaking this with vinegar, cleaning it up with alcohol. It looks better, but it still, the battery leakage did cause quite a bit of damage on traces in this area, which I'll call ground zero. I replaced these 4 components. I think earlier I said there were 3 resistors in the cap. That was false. There's actually 3 caps. These 2 you can see, which are the startup caps for the crystal. Has a resistor for the crystal amplification circuit, and hiding behind this is just a bypass capacitor. So those got changed. cleaned, and then I started to measure traces, measure connections. So on this side, well, nothing was done other than cleaning on this side. But on this side, ended up with replacing a few connections where the traces had been eaten off. And some of them were strange because the connection between here and here, for instance, that's far away from ground zero, which is over here. But it turns out, if we look at it on this side, it's a connection between this chip, this chip and this chip. And basically what happens is the way this got routed is that the trace connecting those two goes straight through ground zero. And, well, we all know what happens in ground zero, so let's, I measured and measured. It took a long time, but let's see what, if anything, we've achieved. Okay, it's back in the case. I don't have the drive connected or anything like that. Just the front panel switches and the display. And off we go. Okay, I guess a big hooray is in order because it actually came up. I mean, this is a big difference between what we saw last and what we see now. But unfortunately, it seems to get stuck right here. No response, nothing. So if we try it again, we can see that it's resetting all of the RAM and everything, because I haven't put a battery in it yet. But it does this stuff, initializes, goes back to the title screen, and gets stuck forever. So just as I was too exhausted to jump up and down when I saw something appear on the display, I'm also too exhausted to continue, but hey, you got to push yourself. Anyway, what I did was I started poking around, started to come up with why does it stop right here? And it seems that what it's doing, it's reinitializing all the RAM and then rebooting, but then it gets stuck during the reboot. And my guess is that there's still something wrong, that we still have a tracer or two that doesn't connect properly. But the way I've kind of verified this was I put a scope on it, and my guess was that during initialization the interrupts are disabled, but then once it's done and it wants to actually start up, it will enable the interrupts. I was right about that because I probed the timer interrupt that gets generated, and it does run. It comes up. Uh-oh. It's doing weird stuff now. Oh, that's interesting. Adjust viewing angle. And that doesn't work. I mean, these are the symptoms of, I mean, something's not connected. Something's floating and is getting pulses from here or there, but it definitely has something to do with the interrupts. I think, at least. I mean, if we have bad luck, I have bad ROMs or bad anything else, but I've seen this kind of behavior before, where it starts acting up weird when the interrupts come into play. So let's go in and probe all of the chain, the timer interrupt, and how it gets to the processor. Well, it took me a while, but my guess was right. I did find out that the timer interrupt, which comes out of here, wasn't making its way to the timer encoder. The interrupt encoder, which tells the processor what level interrupt to perform. The funny thing is I had a mark here. I don't know if you can see it. This pin was marked. So I must have found something, but sleeplessness made me ignore it. But yeah, there was no connection between here, and the red wire should fix that. So let's give it another try. Okay, for yet another try, and here we go. Power, it's going through that stuff again. Alright, it didn't get stuck. So I think it actually powered up. Now, well, let's see if it takes commands. Adjust viewing angle of LCD using the increment decrement. I think it's these buttons, so. No. 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 So it's not taking button input, but that may be because it looks like I didn't push the connector in. Crack. Okay, now, yep, can make it disappear and bring it back. So it is accepting commands, and then I guess that's it. We're done. Yep. So it is taking commands now. Let's just make sure that that'll boot up a second time. And we're back here, and yeah, it is taking input commands. Oh, no disk in drive. Well, electronically the disk seems to work. Configuration. All right, so we're somewhere. There's still a lot left to be done on here, but I think we got the base fix. We're going to turn our attention to the disk drive. It's kind of funny because it says there's no disk in drive, and then it wants you to format it. But what we're going to do is take it out and give it a little cleaning and maybe some lubrication on the drive rails, and then see if the drive works. This is a double-sided, dual-density 800K drive. And they're kind of hard to come by now, because obviously when we went to the high-density discs, nobody wanted these anymore and everybody threw them out. But a lot of musical instruments from the 80s and even early 2000s were still using the low-density, well, I'm sorry, the high-density dual-sided drive 800K versus the, what was it, 1.44 meg drives that were on all of the PCs. This is how many screws I had to remove to get the drive out. I guess it makes for a sturdy build, but not super maintenance friendly. Anyway, this is a Sony model MPF 420-1, and we have some more disassembly to do to get this top metal part off, so we can access the drive mechanism. And I think we only have another 4 screws left here, and then we're ready to rock and roll. Alright, we're in. I'm not going to do a whole lot with this because I don't want to take this mechanism here out. But what I can do is the worm gear here seems to be rather dry for the, that's the head positioner here, and clean the heads, because it's dual-sided, so it has 2 heads with some isopropyl alcohol. and then put it back together and give it a try. Now for the next big test, let's see if the drive actually works. We'll do that by formatting a disk, and while watching that interesting format happening, we'll talk about what's left to be done on this device. Press start to begin, examine the disk, and go ahead. Is it doing anything? Looks like it is. Let's see if it gets through it. And while we're watching that, the things left to be done, of course, are, I think I'm going to put a battery in next over here. I'm going to put a small coin cell in there, which I wish I could say they never ever leak. They do. I mean, I've seen a couple of coin cells that were bulged and there was stuff coming out of them, but I'll just put a holder in there. And then another thing we have to check is the actual MIDI ports back here, because they're close to ground zero, and the optos are here for it, and we need to see if that is that's working or not. And we'll just pump some data into it and try to read it back, save it to disk, read it back, and that would probably complete our effort on this wonderful piece of equipment. Well, we're getting close. It's going to go all the way up to, or should go all the way up to 79 tracks. And we're there. No bad sectors. And that's fantastic, because the disk drive is good. So I installed this battery in the holder. And the original battery was a 3.6 volt NiCad, rechargeable. These are only 3 volts, but it still generates more than enough voltage to keep the SRAMs that it's feeding alive through power cycles. The only other thing I had to do was, since this is not a rechargeable battery and you try to charge it, then really nasty things will happen. I replaced, it had a current limiting resistor between the positive terminal and the power, the 5 volt power. I put in a blocking diode with the anode facing the positive terminal here, and what that does is it's not going to try, obviously I don't need the current limiter here anymore because there's no current supposed to flow inside. And the diode will make sure that it doesn't recharge, but it will let the voltage or the current through when the 5 volt disappears. I've already tested it, and it is holding the configuration data through several power cycles. Well, that brings us to the end of part 1. I would like to mention that one of our viewers, Jan Stavel, made a generous donation. Thanks, Jan. And other than that, please like, subscribe, and all the other good stuff. And next time, hopefully we'll be able to finish this up by testing the MIDI circuitry over here, which is close to ground zero, and then actually make it do what it's supposed to do. See you then.